Find the coordinates of the stationary point on y equals x to the 4. Investigate the nature, starting with the second derivative test. So if we have y equals x to the 4, then the first derivative, dy dx, would be 4x cubed. For a stationary point, we need 4x cubed to be equal to 0, and that only happens if x is equal to 0, and if x is equal to 0, y is equal to 0, so we have a stationary point at 0, 0. The second derivative is going to be 12x squared. And so the second derivative, evaluated when x is equal to 0, is 0. Now, let's do it with a sine table. So, x value, so we know that the turning point was actually, or the stationary point is actually at 0. Go to the left and go to the right. And then let's look at dy dx. Well, we know it's 0 here. At -1, that would be, sorry, that's the second derivative. At -1, the first derivative, dy dx, is 4 times the -1, so it's going to be negative. And if x is equal to 1, then 4x cubed is positive. So we have downwards, across, and up, and that is a local maximum. So it's a local maximum, but the second derivative was 0. The second derivative test, if it comes to 0, tells us nothing. The second derivative is always 0 at a point of inflection, but when the second derivative is 0, it doesn't necessarily tell you that you have a point of inflection.